Another video on AA learning. Just before we get into the video, sorry for the upload schedule being weird. I was out for a bit, but now I'm back, so the upload will be better. Yeah, so today we're gonna do a topic that's related to calculus, of integration of partial fraction decomposition. So this topic you mainly see in a calculus BC class if you're in high school, or a calculus 2 class if you're in college. But in order to actually do integration partial fraction decomposition, you have to know what partial fraction decomposition is. So partial fraction decomposition, or I'm just going to write it as PFD, is basically used when you have rational functions that are in fraction form. So let me show you guys what that looks like. So usually in when you're doing PFD, you have a function, it's like f of x, but I'm just using c of x here, divided by another function, which I'll just show as d of x. Again, c of x, d of x are just like f of x, just different variables. Okay, so basically, whenever we have this form, we can use PFD. And what PFD allows us to do is just simplify this into more simpler terms, I guess. So usually we use the variables of uppercase A, uppercase B, and go down the alphabet. But what we would do is write A and then whatever's in the denominator. Usually it's factors that should be in the denominator that make it easier for you to write it out. So it should be x minus A or something like that, and then plus B of maybe divided by x minus B. And we simply just got these factors because they were in the original denominator here. So basically what we did was just take this big mess that we had and then simplify it down into something easier for us. And later for the integration aspect, it'd be just easier for us to integrate two smaller pieces than this whole mess we have here. So that's what PFD allows us to do. Before we get into some examples, there are some rules that you guys need to be aware of. So when solving for PFD, the denominator, which we labeled as d of x here, that has to have a higher degree compared to the numerator, which we labeled as c of x. So basically, say if c of x was x squared, then d of x has to be a degree higher than that or something. It can't be lower than that, basically. Okay, the next rule is that d of x, the denominator, it can be factored. That's also important for you guys to know for these type of questions, because sometimes a question may not give you in the factors. You just have to factor it out and then identify which factors are there for the denominators when you're separating them out. Okay, overall, just PFD helps with simplifying this expression to a more simple and understandable problem. Okay, let's get into some examples so hopefully it's more clear. Okay, so our first example we have, I'm just gonna add the integration sign even though we haven't gone over integration of this, but I'll go over it. So the integral of 3x plus 5 divided by x plus 1 and x minus 2 dx. Okay, well, if we can see for this question, it's already factored for us, the x plus 1 and x minus 2. If it was FOILed out and everything, then we would have to put it back in this form. Okay, so let's just solve this one step at a time. Right now, I'm not going to worry about the integration at all. I'm just going to take this piece right here. So I'm going to have 3x plus 5 divided by x plus 1 times x minus 2. Okay, so remember, we use the variables, we go alphabetical order and uppercase. So it'd be A, and then I usually go in order, so we'd use this denominator that we have right here of x plus 1, and then we'd do the plus sign, and then we have B here, and then x minus 2. Okay, we have our two like factors. Now we can't just leave it like the variables a and b. We actually have to solve for a and b. So how do we do that? So our first goal would be is to cancel out these denominators that we have right here. These. Because that's kind of like messing us up because we need to just solve for a and b. So what we have to do is let me rewrite this equation right here. 3x plus 5 divided by x plus 1 and x minus 2. And that will be equal to, now we have to multiply all this to the a's and the b's. So that would be like this. A times x plus 1 times x minus 2 divided by x plus 1 plus b times x plus 1 times x minus 2 divided by x minus 2. So what that allows us to do is we can cancel these common terms right here that we have, and it allows us to also get rid of these denominators here. Now that'll make more sense and more clear why we do that, because we're solving for a and b. So now we can just simply rewrite this as 3x plus 5 is equal to a, now let's just see whatever we have left here, x minus 2 plus b times whatever we have left there, x plus 1. Alright, perfect. Now we just need to solve for a and b. So we still have just 3x plus 5 is equal to, let's distribute this. So that would be ax minus 2a plus bx plus, just for the sake of it, I'm going to write 1b. Okay, now we have this. So our goal is to make this 3x plus 5 equal to the side of ax minus 2a plus bx plus 1b. So you want both those sides to have the same values, like equal to each other. Okay, so what we have to do here is do this. So we have 3x plus 5 is equal to, we have to group this side all together. Remember, you don't group the a's and the b's together. You have to group the x's, and these are constants. So the a of x, which other value has an x? The b of x. So you would group them as a x plus bx, and then you group the constants. So that'd be minus 2a plus 1b. Okay. This is important, you guys remember. You don't group like if it has a and a, no. You have to use if it has x and x. If it's a constant or constant, if it's x squared, you have to do like kind of like that. Okay. Now let's see if we can simplify this even further. So it becomes 3x plus 5 is equal to, we can take out an x here, so it'll be x, and then a plus b minus 2a plus 1b. Okay. Now this is where we have to do some algebra. Okay. Well, we've been doing algebra, but yeah. Okay. So we have this a plus b term right here. I only want it to match this 3. So what I would do if I was doing this on paper, just go to like the separate side of the paper where you guys haven't done any work, and then so that way you guys don't get like confused or mixed up. So this would be a plus b is equal to, rewrite that, is equal to 3 right here. And then we would have, because we already have this x term right here, there's already x, so we just need 3. So that's why we set that equal to 3. And then we have to do negative 2a plus, I'm just going to write b now, because hopefully you guys got the idea, that's 1b, is equal to 5. Alright, what we have here is 2 equations basically. Now there's 2 ways we can solve for variables a and b. Either, I'm gonna go over like what I usually do, but you can also simply just like create these 2 equations and do a systems of equations type thing. So multiply this by like 2, that way it becomes 2a plus 2b equals 6, and then cross out the 2a's that we're solving for b. But I'll show you guys what I usually like to do. So what I do is I'll just pick a variable to solve for. So I just choose a. So a is equal to 3 minus b. Okay, now we have to substitute this a in for this value right here. So negative 2, and then 3 minus b, because we know a is equal to 3 minus b, plus b is equal to 5. Okay, all I did was just solve for any of these values. I could have done the same thing for b, but I just randomly chose a. It doesn't matter. Okay, so now I just plugged in a here, and now just distribute these. So this would be negative 6 plus 2b plus b is equal to 5. So this would give us, just moving that 6 to that side, and combining these terms, it would be 3b is equal to 11. And then we can just divide and find out that b is equal to 11 thirds. Okay, we found out what b is equal to. So how do you solve for a? Well, we already can just plug it into this equation right here. So we know a is equal to 3 minus 11 thirds. So we know 3, that's the same thing as 9 thirds because we want the same denominator when it's subtracting fractions. So it becomes 9 thirds. Oh, that's a terrible 9. Minus 11 thirds. So a would equal negative 2 thirds. Okay, I'm gonna go to a separate piece of like sketchpad paper, but like this is just the PFD part. I want you guys to be aware. Next part we're gonna be actually like integrating. So now that we have our values of a and b. Okay, so we had the integral of 3x plus 5 divided by x plus 1 and x minus 2 dx. Okay, and we had that equal to a over x plus 1 plus b over x minus 2. Okay, and we knew that a is equal to what and b is equal to what, and we knew b was equal to 11 thirds and then a was equal to negative 2 thirds. Alright, perfect. Okay, so let's just plug in the values we know. So we know a is equal to negative 2 thirds. So what we would do is that would be negative 2 divided by 3 times x plus 1. Okay, because the 2 thirds is right here, I want you guys to realize you can do that. And then the plus sign would stay, and then there would be 11 divided by 3 times x minus 2. If we were just doing PFD, we'd be done. But we're also trying to integrate here. So I'm going to add back the integration signs here. What I would recommend you guys do is just write the integration sign on a whole new line, but I'm just doing this because, yeah. Okay, so now in order to integrate this, you have to move the negative 2 thirds and 11 thirds to the front of the integration sign, of their own integration sign. Think of these as two different integrals. You're just trying to take the integral of this and the integral of this. Okay, so let's first do this one. So negative 2 thirds would come to the front, and that would be 1 over x plus 1 dx. And whenever we have a fraction like this with 1 over x plus 1, we know we have to use our natural log. So this would simply be negative 2 thirds natural log of absolute value of x plus 1. Okay, we have this one. So now let's focus on this side. So we're trying to we can move that 11 thirds to the front. So that'll be 11 thirds integral of 1 over x minus 2 dx. Okay, this plus sign will just drop down right here. So what we would do is just do the same process. So this would be 11 thirds would stay in the front, and then it'd be natural log. And remember absolute values of x minus 2. And this time don't forget the plus c whenever you're integrating. And that would be our final answer. So the integration part, in my opinion, is the easier part, as long as you guys know like the actual properties of how to integrate. But the PFD just involves a lot of algebra, and like one simple mistake can like ruin your whole problem. So you guys have to be careful. And I want to like give a quick reminder, or like just like rule that you guys need to know for PFD. So when we have this a over x plus 1, that's a linear factor, x minus a, or x plus 1 in this case. So whenever we write that, we'd simply just write it how it is, like right here. That's correct. But if we have like repeated factors, like x minus a like squared, we'd have to write it like this. We have to do a over x minus a, and then plus b over x minus a squared. So basically you guys have to count like the squared is like implying 1 and then 2 terms like that. And if it's like third, you have to do a, just like keep doing it to the third power. So you have to do plus c. So you guys have to remember that rule. If it's like, here, let me just write it down. So if it's like third, you guys have to know it's like x minus a, that's the first, just write like first power, and then b, and that's like x minus a, that'd be squared, and plus c, which should be x minus a cubed. And that's saying if one of the factors was like x minus a cubed. If one of the factors in this like denominator of the original function. Okay, and our final rule is like if we have any quadratics that may be written like x squared plus or minus a, then we have to write our a, b, c like numerator parts a little different. So what we have to do is, because the denominator is x squared, it'd be a higher term. We have to do we have to rewrite it as like ax plus b divided by x squared plus or minus a. Okay. The reason we have to do this is because, remember, the denominator is always greater than the numerator. So that's what this would imply. And that's why we have to write it like this. If you got, there's some practice questions that I have I'll link to the comments again. They'll use some of these rules. So make sure you guys are just careful when doing that. Okay, let's go into the next problem. Okay, we'll just call this question 2. Okay, so our next problem is the integral of x squared plus 3x plus 5 divided by x plus 1, and remember dx. Okay, so right away, if we have to first do, let's check for PFD, right? If PFD applies. Remember our 2 rules. We can factor it, and our denominator has to have a higher degree than our numerator. Well, if we're saying that, then our rule is broken, because the numerator has a higher degree compared to the denominator, which only has a power of 1, which the numerator has a power of 2. So what would you have to do in this case? So you don't just rush into PFD like this. You have to actually do long division. If you're like above by 1 degree, you have to do long division for this. If your numerator is above 1 degree than the denominator. And if you guys need a refresher on long division, I can create a video, just let me know in the comments, but I'm assuming you guys know how to do it, so let's go over that. So we would have the x plus 1 in the bottom because of this right here, this term, and then we just divide that by this whole thing over here. So it'd be x squared plus 3x plus 5 divided by x plus 1. Okay, all we have to do is put x right here, because x times x, that's x squared. And remember, whenever we're dividing, we're subtracting here. And then this x also goes here, so that's plus 1x. Alright, let's see how that would be. These terms would cancel out, and this would be 2x. And this 5 would drop down. So it'd be 2x plus 5. Now we have to add a plus 2, because we can cancel out that 2x over there too. So that would be, when we're distributing, it would be minus 2x, and then right here, the plus 2. Now we can cancel out this 2x together, and then we'll have a 3 right here. And we can't really do anything with that 3 because there's an x term. If we add a 3, that'll be 3x. Can't cancel out a 3 and a 3x together. So what that would give us is our remainder of 3. So I'll just draw an arrow and write r. Okay, so our final answer just for the long division part would just be x plus 2 plus 3 divided by x plus 1. Okay, now what we would have to do is just integrate this. So basically this is kind of like our PFD. We basically took this whole mess that we have here into this more simpler part that we can integrate. But remember, we just have to use long division whenever the degree is higher in the numerator than the denominator by 1, and it's in fractions. So let's take the integral of this. So we have this, and dx, and let's just draw the integral sign. So just treat these as separate integrals. So the integral of x dx plus the integral of 2 dx plus the integral of 3 over x plus 1 dx. Okay, so we should know how to do these simple integrals. So that would just be x squared over 2 and then plus 2x and plus this one is going to be the natural log, and remember the 3 goes in the front. 3 natural log of absolute value of x plus 1, and then don't forget the plus c, and that would be our final answer for this question. So what I'm trying to imply is that not all the questions that you guys will see will have simple PFD that we had in the first question. So let's go to our last example for today. Okay, so our third example is the integral of 1 over x squared plus 4 dx. Alright, what do you guys realize when you see this problem? Hopefully you guys see that you do not have to do PFD for this question. Basically, all you have to do is, hopefully you guys have this memorized, is the integral of 1 over a squared plus u squared is equal to 1 over a arctan, or inverse tan, of u divided by a, I don't know why it's going slanted, plus c. You guys have to have this formula memorized. I know if you're taking the high school AP Calc AB or BC exam, you guys have to have this memorized. And yeah, so this rule just implies just simply like that. So a is the constant, so the a would be the 2. We know the u would be the x because these are squared, so we just square root it. And the answer would just be 1 over 2, and then arctan, or inverse tan, of u divided by a, x over 2, plus c. And that's our final answer. So again, I'm just showing you not all questions will use PFD. You guys have to be careful about when you use it and when you don't, especially when integrating. So when integrating, you just have to it's process of trial and error. So there's going to be a practice worksheet in the comments if you guys need it. And yeah, thank you for watching.